first is an isosceles right triangle, or also referred to as 45, 45, 90 triangle. Okay, so if I gave you an isosceles right triangle and I told you the length of one leg is 3, could you find the lengths of the other sides? Could you find B and C? Okay, see if you can do that just very quickly. B is pretty easy, right? What's B going to be? It'll also be 3. And so now if we have that, we can use Pythagorean Theorem. 3 squared plus 3 squared is equal to C squared. 9 plus 9 equals C squared, and continue to solve this. Extracting the square root, we get C is equal to what perfect square factor can you remove from 18? So the square root of 9 times the square root of 2, square root of 9 comes out as a 3, and the 2 stays under your radical. And so you get the length 3 root 2. And now, if we were to generalize this, so instead of using these specific numbers, let's say we generalize it into an isosceles right triangle of legs x and x. Could we find what this hypotenuse, we'll call it C here, is equal to? If we use Pythagorean Theorem, x squared plus x squared is equal to C squared. Combine these. You get 2x squared is equal to C squared. And then extract your square root. The square root of 2 stays as it is. The square root of x squared can be simplified into an x. And so you wind up with this pattern of x root 2. Now, is that true? Does that hold true here in this example? 3, 3, 3 root 2? Yeah. If you can be familiar with this pattern. Now, on SATs, it's provided for you. They actually give you this pattern on the reference information. And however, if you don't need to refer to it and you understand how to manipulate it, it can save you a lot of time. Because when you're working with 45, 45, 90 triangles, and they give you one of the legs, it should be very easy to find the other pieces. The other leg is the same length, and the hypotenuse is that leg times root 2. It fits this pattern of x, x, x root 2. Does everybody see how that pattern works on this basic case? Okay, now, the next, if you increase the difficulty of these slightly, the next one would be if I gave you the length of the hypotenuse. So if I told you the hypotenuse was 8, but it would be in the form of the pattern. So if I told you the hypotenuse was 8 root 2, could you then find what each leg is? It still fits the pattern directly, so each leg is going to be 8. It's x, x, x root 2, so that means that this is your x value. Okay, the difficulty comes when they give you, or actually let's go through one more before we get to the most difficult ones. If they give you the length of each side and it has a radical in it, so let's say the side length is 2 root 3. Okay, so if there's a radical in the side length, 2 root 3 would be the other missing length, and the hypotenuse would be 2 root 3 times root 2. It still fits that pattern, x, x, and x root 2. And then you just have to simplify. When you multiply two radicals together, you can combine their products inside the same radical. So root 3 times root 2 is just the square root of 3 times 2. So 2 root 6 would be the length of your hypotenuse here. Okay, any questions on these? These are what I would consider the easy applications of this. Okay, the more challenging application comes when the given piece of information is the hypotenuse and it's not written in that square root 2 form, that x root 2 form. Okay, now, this length of 10 is still equivalent to x root 2. Okay, so it is still equal to x root 2. So if we wanted to find what x is, again, because we're looking at this pattern, right, x, x, and x root 2, we would have to divide by root 2. Right? And if you recall from algebra, which hopefully you guys do recall, when you rationalize a denominator, meaning you can't leave a radical in the denominator. So when you rationalize a denominator, you have to multiply through by root 2 over root 2 in this case. And that gives you 10 root 2 across the top. Root 2 times root 2 is root 4, which is just a 2. And so really what you wind up doing is you simplify by performing these operations. You divide by 2, and you multiply by root 2. Okay? This is the pattern for simplifying. Right? It's the most difficult one, but if you understand this pattern, it winds up being just as easy as all the others. Okay? And so the pattern is just take 10 divided by 2, which is 5, and multiply by root 2, and that's the length of each side. So 10 divided by 2 times root 2 is the length of each of these sides. Okay? So as you're going through these, you should be able to answer them very quickly. Okay? So if I give you 12 here, what's the length of each leg? 12 divided by 2 is 6 times root 2 would be the length of each leg. Okay, what if I gave you, again, this only works for 45, 45, 90 triangles, but what if I gave you 18? What would be the length of each leg? 18 divided by 2 is 9 times root 2, so that would be the length of each leg. The last thing, or the most challenging thing, would be if I gave you an odd number instead of an even. So if it wasn't divisible by 2, the pattern still holds true. If you're dealing with an isosceles right triangle or a 45, 45, 90, you're still going to take your hypotenuse, divide it by 2. So we take 17 halves and multiply by root 2. So the pattern still is fulfilled. It winds up being a really easy set of problems if this is the case. It's just a matter of making sure you follow this progression. If you're given the hypotenuse, divide by 2, multiply by root 2. So
Why do you divide the hypotenuse by 2?
it's when you rationalize, division by the square root of 2, when you rationalize it, turns into this process of dividing by 2, multiplying by root 2. So we're just kind of taking that shortcut and applying it directly.